Good morning, Year 5, Miss Biggs here. Welcome to your Friday's maths lesson. Today, can you put today's date and learning objective? We're going to compare and order fractions, but today we're going to move into ordering fractions that are greater than 1, bigger than 1 whole 1. We're going to be doing the first half of the worksheet, and the other half we're going to be doing on Monday. Please pause the video and do your flashback 4. When you've done it, come back and check your answers. How did you do? You should have seen half would be 6/12, so 7/12 has got to be more, it's greater. Changing that to an improper fraction, 5 times 2 is 10, add 1 is 11, 11 halves. Dexter gets that amount of pocket money in a year, he gets £936. And the missing number is 70, because 70 take away 47 makes 23, and the time is 12:20. Into today's learning then, we're going to be comparing and ordering fractions that are greater than 1 today. But let's warm up our skills, get ready. Convert so they are equivalent before you compare. Let's see how you did. You should have thought, to make these into the same common denominator, I would have to multiply 9 by 3 to make it into 27. So multiply 2 by 3 to make 6. Well done. Here we're going to compare 7/9 and 14/18. So one way to do it would be to double 7 to make it into 14. Whatever I do to the numerator, I do to the denominator. Double 9 is 18. You should have found when we convert that into an equivalent fraction, they are exactly the same. So therefore they are equivalent. For this one, for number 3, whatever is on this side as a fraction must be greater than 1 whole 1. Well, if it was sevenths as 1 whole 1, that would be 7/7. So to have more than a whole 1, you can have any number here that is greater than 7. For example, 8/7 will be greater than a whole 1. You could actually have any integer that's greater than 7 here. So 7, you could have 8, 9, 10, and so on. On the last one, I'm going to think about comparing. And this is going to convert so that the numerator is the same. This time, 1 we times by 2 to make into 2. So we do the same to the bottom. 8 times 2 is 16. And if we look at that when the numerator is the same, then the denominator, the greatest denominator, makes the smallest parts. So therefore this is smaller than this. Let's learn. We're going to be using our symbols again to compare the fractions. Have a think. What do you notice about these fractions in this part of the lesson? We're going to still be using our same rule. When the denominators are the same, and they are both 7, then the greater the numerator, the greater the fraction. Therefore, 11/7, let's look at it. Well, there's 7/7, and then we've got 11. And for 9/7, well, there's 7 of them, and 2 more makes 9. And you should be able to see that 11/7 takes up more space than 9/7. Therefore, 11/7 is greater than 9/7. Let's have a look at these. Now, nothing is the same. So we have to think about which rule we're going to follow to help us with this one. Now, 7 and 13, there's not really a relationship. But with 5 and 10, there is. So we could double 5 to make 10. Whatever we do to the denominator, we do to the numerator. Double 7 makes 14. And we should be able to see, therefore, that that would be 1 more than 13/10. So therefore, this one is larger. When the denominators are the same, the greater the numerator, the greater the fraction. So 14/10 is greater than 13/10. use what you've learned and think about whether to use your numerator rule or your denominator rule to convert these before you compare. Pause, have a go, come back to me. Let's see how you did. So in the first one, well, the top numbers, there's no relationship. So let's have a look at the denominators. There is a relationship. I can double 12 to make it into 24. Well, if I double 12, I must double the 16, and double 16 is 32. When the denominators are the same, then the larger the numerator, the larger the fraction. So this side is larger. Let's have a look at these. There is no relationship between these, but there is between the denominators, because 7 goes into 21 3 times. So 7 times 3 to make it into 21, 10 times 3 is 30, 30 over 21. The greater the numerator, the larger the fraction is that you have. Therefore, 10 sevenths is greater than 26 21sts. With this one, we're going to have a look. Now, there's no relationship between 89 and 6, but there is a relationship between 4 and 44. I could multiply by 11. So 4 times by 11 is 44, and 6 times 11 is 66. Therefore, 89 44ths is greater than 66 44ths, which is greater therefore than 6 fourths. There is another way we could look at this one on the bottom. Let's have a look at the relationship on this side. Now, if I double 44, I get 88. So one lot of 44 44ths would be one whole one. And 89 is more than or greater than double the 44, because double 44 would be 88. It's one more 44th. So I therefore have more than 2 whole ones. On this side, 4 fourths would be 1 whole one, and 8 fourths would be 2 whole ones, but I don't have 2 whole ones. So this is less than double, it's therefore less than 2 whole ones. And by comparing like that, I can see that this side, being greater than 2, is greater than this side, which is less than 2 whole ones. Let's have a look at this one. Here I can see the numerators are the same. So which rule am I going to use? Let's have a build it session. Here we have 13 13ths, and here and 15 13ths altogether, and here we have 15 tenths. And we can clearly see that 15 tenths is greater than the 15 13ths. Remember, if the numerator is the same, and the denominator tells us that these parts are smaller pieces, and we can see that visually here, those pieces are much smaller, whereas the tenths take up much more space. When the numerators are the same, the greater the denominator, the smaller the fraction. Let's think about this one. There is no relationship here, but there is a relationship here. I could multiply the 9 by 3 to make 27. So I will. I'll make 9 times by 3 is 27. So 3 times by 3 is 5 times by 3 is 15. 27 24ths and 27 15ths. When the numerators are the same, the greater the denominator here, the smaller the value of the fraction. So this side is smaller. Let's have a think. Pause the video and have a go at this one. Look for the relationship. Well, there is no relationship here, but there is a relationship here. I can double 4 to make 8. So I double 4 to make 8, and I double the 5 to make 10. So this side is equivalent to 8 tenths. The numerators are the same, so the greater the denominator, the smaller the fraction. Therefore, this side is smaller, and this side is larger. So 8/7 is greater than 4/5. We can see also, if we apply our knowledge, 8/7 we can clearly see is more than one whole one, because 7/7 would be one whole one. Whereas on this side, 4/5, I don't yet have a whole one. That's less than a whole one. So I could work it out without having to find any comparisons. Let's have a look at this one. Rosie here and Amir here both have baked some cakes. I can't blame them. They've both got a little bit hungry and eaten part of the cake. Rosie says, I've got 2 whole ones and 3/4 cakes left. Whereas Amir says, I've got 2 whole ones and 6/7 left. So I'm wanting to know who has the most cake left. So we're doing a comparison between them. Here I've got Rosie's amount and here I have Amir's. What's the same about each mixed number? You should have spotted that they both have 2 whole cakes. So we can park those off to one side. We only need to compare the parts that are left, 3/4 and 6/7. Is there a relationship between those parts? Let's make it so that the numerators could be the same. Well, I can see that I could change 3 into 6. I would multiply it by 2. So therefore I do the same to the denominator. I times it by 2 and I get 6/8. Now I'm comparing 6/8 and 6/7. When the numerators are the same, the greater the denominator, the smaller the fraction. So here we can see that 8 is greater and therefore it is a smaller fraction. So therefore, who has the most cake left? Amir. He's got the most cake left. There's another way we could look at this. Who's got the most cake left? What's the same about each fraction? Well, we can see that Rosie has still got 1/4 to get to 3 whole cakes, whereas Amir has 1/7 to get to 3 whole cakes. When the numerators are the same, the greater the denominator, the smaller the fraction. So this side has a smaller distance to get to 3 whole cakes. Let's build it. We can see here Rosie's 1/4 left, and here we can see Amir's 1/7 to get to the end. Therefore, he's got more cake left. Have a go at questions 1 to 4 on the worksheet and stop when you get to there, because that will be the learning complete for today. I'll show you how I'd like you to complete that in your learning, in your book. Use this to help you if you need to. Layout in your book, number 1 I'd like you to stick in, and then from number 2 onwards I'd like you to write it in your book as shown, putting your symbol in the circle in the middle. Continue to the end of question 4, then you stop. You will do the rest of the worksheet on Monday, but please hand in all of your work today. We will recopy the worksheet to give you for your work on Monday, and you will receive it in today's learning pack. Don't forget to come and collect your learning pack after 12:30 today, and then hand in your work from this week. Well done on your learning this week, and I look forward to seeing you next week. Goodbye.